morning. Many years ago, scientists discovered that if you light a candle like this candle here and put it in a tray of water and then invert empty beaker over it like this, that the candle will begin to subside and the water will rise inside the beaker. So you see, when the candle burned out, some water rose in the beaker. So therefore then, there is something in the air which supports combustion. And this gas is called oxygen gas. So oxygen gas is about maybe 20% of the air, and also it is found combined in water and sand and silicate minerals. Today we shall prepare oxygen gas by decomposing hydrogen peroxide. Hydrogen peroxide is buried in your kitchen, in your melting cabinet. If you have a bad cut, add a small amount on your skin, and this should sterilize the wound. I have the same chemical, hydrogen peroxide, in this container. And I'm going to add a chemical called manganese dioxide, which acts as a catalyst for this reaction, a catalyst. Hydrogen peroxide will decompose very slowly, but if you add manganese dioxide, it will speed up the reaction. I'm going to add a small amount of hydrogen of manganese dioxide into this container. And before I do this, please notice that this tubing connects to a trough. The opening above the trough, I have this bottle filled with distilled water above the opening. So when the oxygen gas escapes, it will displace the water. Let me try this. As you can see, right away the reaction begins and going very fast. I'm going to slide this way and put the next bottle down here. You see? Okay, and then the same with this bottle here. So as you can see, the catalyst really speeds up the reaction. Okay, and one more. Okay, I can wait for that for a while. I can wait for this. I'm going to try to collect as many bottles as I can. I need about maybe 5 bottles. Of oxygen gas. Okay. Okay. The extra water should escape into the sink. Okay. So now, before I remove each bottle, I'm going to have to use a glass square under the opening. Okay. My first bottle, which is placed right here, and the same with these bottles here. This bottle, slide the square under it, upright, and so on. So I need about 5 bottles Okay. And one more bottle. Now near the end, you expect, of course, to slow down because I'm using up the hydrogen peroxide. So now I have prepared 5 bottles of oxygen gas, and you may notice that each bottle had a small amount of water inside the bottle. I need that water. Okay, and here is the last bottle. Okay, good. Okay, I have labeled these bottles sulfur, phosphorus, and calcium and magnesium. Okay, next I'm going to light the Bunsen burner. Most elements combine with oxygen to make oxides. I'm going to ignite a few elements for you, 2 non-metals and 3 metals. I shall begin with the phosphorus, with sulfur. That yellow substance is ground sulfur. To protect myself, I'm going to use this spoon called deflagrating spoon and take a small amount of the element sulfur, and then I'm going to heat that and slowly it will melt. It is now melting and burning. I'm going to insert this in the bottle which contains oxygen. Okay. It should burn with a blue flame. The flame is blue, kind of a dark blue flame. Let it burn for a while. While burning, the sulfur becomes sulfur dioxide. Okay. Let it burn for a few minutes. Remove it and slowly extinguish the flame. I shall repeat this experiment using red phosphorus. Red phosphorus. Phosphorus comes in 2 types, red and white. This one is red phosphorus. Again, first I'm going to heat it, and this time you can see it gives off this thick white smoke. I'm going to put this now into the second bottle. It's a very bright smoke screen. So phosphorus is burning and combining with oxygen to make one of the oxides of phosphorus. This is sufficient. Remove it. As you can see, I'm working under this fume hood, so I don't have to inhale any of these gases. So this is sulfur and phosphorus. Next, I'm going to heat a lump of steel wool. It's iron, made of iron. And I need to hold this with a crucible, with a crucible taunt. Again, so I don't have to burn my hand. Again, light, place in the flame, and then place it right here, above the water. Okay, and then cover it and remove it. A fresh piece of magnesium turning. Well, it's been oxidized anyway. That white layer is magnesium oxide. We'll try. That should really flare, but because of the airflow, I guess, and the Bunsen burner are not hot enough. Anyway, we have now 5 bottles. Okay. Let's now look at each of these solutions. When the elements are ignited and the fumes mix with water, they produce either acids or bases. So I'm going to use litmus paper, which can tell us if the solution is acidic or basic. I'm going to use the blue litmus paper, 1 or 2 strips. Placed in the first bottle. I can turn this off now. And allow it to mix for a while. As you can see, the blue litmus paper became red, which indicates the solution to be an acid solution. The sulfur oxide and water will produce an acid solution. Next, I'm going to try phosphorus. Again, as you can see, it will turn red from blue to red, which indicates this medium now is acidic. The next three solutions, which contain the elements iron, calcium, and magnesium and calcium. With iron, with this I'm going to use the red litmus paper and see what happens to it. Okay, I can see that the red litmus paper remains red because iron oxide not very soluble in water. Next, I'm going to try the calcium and magnesium bottles. And here you can see it is turning slightly, turning. We'll leave it for a while. Then the last one. Turning blue. So the two metals oxides produced bases, the two non-metal oxides produced acids. Okay. Now, as you know that oxygen is required for combustion, and combustion you can, when you burn gasoline or you ignite natural gas, they burn very rapidly. Called this reactor combustion. So right here, I'm going to illustrate what combustion means by using this bottle, which simulates your car cylinder. It has two nails, like spark plugs, has a cork. I'm going to add a small amount of alcohol. Ethyl alcohol, small amount. Mix it. Cover it. Now we have a mixture of air and gasoline or ethanol alcohol mixture. I'm going to touch the nail. I'm going to use this Tesla coil, which acts like your car battery. See? Spark. So I'm going to touch the nail and see what happens. So what's happening here is this. The alcohol contains chemical energy. When it burns, it gives off heat. So go from chemical energy to heat energy. The molecules move very fast. They have faster or higher kinetic energy in a small container like this. The pressure goes up. It goes from chemical to heat energy to kinetic energy, which leads to an explosion because the system is closed and the cork flew up.